Welcome to the Enphase Homeowner Video Series. If you've just installed your solar system, you may wonder how the size of your system relates to your energy harvest. In this video, we'll use an Enphase system to illustrate a few key concepts. System size matters, but it's only one of the factors that influences energy production. A solar system size is a simple calculation of the solar panel rating times the number of panels in the system. In our example, the system is built with 14 280-watt panels. This equals a system size of 3,920 watts or 3.9 kilowatts. Where did that 280-watt panel rating come from? Each solar panel's power rating is determined by a test of the panel in a lab in what's called standard test conditions, at 25 degrees Celsius and perpendicular to the light source used to test it. A useful analogy to your solar panel rating is the EPA miles per gallon rating on your car. The EPA rating provides best-case mileage estimates, but you know that your actual miles per gallon varies as your driving conditions change. The same is true for your solar installation, too. Its production changes as its operating conditions change. How do we calculate output, then? Solar panels are also rated on their expected power at the normal operating temperature of the solar cells in the panel. This is usually around 45 degrees Celsius, almost double the temperature in the lab. Solar panels produce less at hot temperatures. So what's the expected power for that 280-watt panel at a normal operating temperature? 209 watts. Standard test conditions result in a rating of 280 watts, but the expected peak power of the panel is closer to 209 watts. Let's take a closer look at 1 day of power production for our sample system. The system never reaches peak power that matches the system's size of 3.9 kilowatts. Why? Because different parts of the system are on different roof planes, none of which face true south. The panels are not consistently perpendicular to the sun as it moves across the sky, and the system was operating at a typical rooftop temperature, not at the temperature of standard test conditions. Now we know how system size is calculated and how it relates to a snapshot of peak power expressed in watts. But your utility charges you for energy expressed as kilowatt hours. How do you translate a system size expressed in watts to how many kilowatt hours of energy that will be for a day, a month, or a year? Power and energy are analogous to the concepts of speed and distance. If a car travels at 60 miles per hour, we know how fast it's going, but don't know the distance it has traveled until we measure how much time it traveled at 60 miles per hour. If the car traveled a constant 60 miles per hour for 1 hour, we could confidently say we traveled 60 miles. Similarly, if a 3.9 kilowatt system produced a constant 3,900 watts for 1 hour, we could say it had produced 3.9 kilowatt hours. Total energy is like total distance in our analogy. So what was the energy production for our 3.9 kilowatt sample system on the longest day of the year? 24.2 kilowatt hours. That would have been hard to calculate based on the size of the system alone. The system's operating conditions needed to be taken into account too. Now you know, size matters, but it isn't the only thing that matters. To learn more, visit our video page at enphase.com/homeownervideos.